So we're going to take a look at nastic responses. Now, a nastic response is a non-directional response to a stimulus by a plant. So you'll probably want to note down that definition. So I'm going to show you a couple of examples of nastic responses. This is the first one. So hopefully you might recognize this plant. I will add the links to our task that have got the YouTube videos. Now, what I want you to do once you've watched it is think about what is the adaptive advantage to the plant using that response. So why is it behaving that way? Why is it using that response? So this is a second example, and this is in the mimosa. Again, I want you to think about what's the adaptive advantage of the response when you watch the video. And just as we've talked about with other orientation responses, they have a prefix. So the prefix for this one is thigmonastic because it's a response to the stimulus of touch. You're going to need to be able to explain why and how these responses occur. So the why will be around what are the adaptive advantages to the plant, and the how is going to be trying to explain how that movement in the leaves actually occurs. So have a go at filling in the gaps on this one, and then if you wait for the next slide, so you could pause it here, and then I will pop up the answers. So here's the same response in terms of how it occurs, and it's all to do with turgor pressure, that movement of water in and out of the cell and giving the plant support. So as I've already mentioned, we'll use the same prefixes that we used when we were talking about tropisms. So chemo for chemical, hydro water, thigmo touch are some of the examples. This time we're not going to use positive or negative because it's a non-directional response. And lastly, a little bit more information trying to help you understand how the response occurs. So normally the pressure would be balanced on either side of the stem, but once the stimulus has acted, then normally ions are moved out of the cell. This will then change the osmotic pressure and the leaves will either fall or close together.